Okay, so here are more trigonometric ratio practice problems. These are the ones where the variables will be on the bottom of the fraction. Once again, I've got another sine, cosine, and tangent example. So we'll go ahead and start with the first one, but keep in mind we're following the SOHCAHTOA as a guideline to make sure that we're using the right trig functions. If you don't remember how to spell it, just remember the some old hippie caught another hippie tripping on acid. So that's a good way to remember how to spell it. So let's start with the first one. The very first triangle has a 76-degree angle. Across from that 76-degree is a side that's labeled as 4, and then across from the 90-degree angle I have the side labeled x. So obviously this is the length that I'm trying to find. And then you've also got this third side of the triangle that you don't have. Let's go ahead and start by labeling our sides of the triangles to make sure we've got the right opposite, adjacent, and hypotenuse. That way we can figure out which trig function we need to use afterwards. So if I'm looking at this 76-degree angle and I determine where the 4 is in position to the 76-degree angle, you'll notice that the 4 is on the other side of the triangle, making it what we call the opposite side. So that's our opposite. If you look at where the x is, it's across from the 90-degree angle, so any side that's across from the 90-degree angle in a triangle is called the hypotenuse. It's the longest side of our triangle, and then the side that we don't have would be the last side, which would be our adjacent. And I'm just going to put like a slash through this just to make sure we are aware that we don't have that side, so we're not really using it when we're trying to figure out which trig function to use. So since we have our opposite and we are looking for our hypotenuse, I need a trig function that uses both the opposite and the hypotenuse at the same time. So if you look at your SOHCAHTOA, I'm looking for one that has O and H. And it looks like the very first one has O and H, opposite and hypotenuse. So that's the trig function that I'm going to be using is sine. So what I need to do is write my equation here. So sine is opposite over hypotenuse, so I need to say sine of a 76 is equal to the opposite, which is 4 over x. And you'll notice that I've got the variable on the bottom. To solve this equation, we use basic algebra. If I want to get the x off of the bottom of the fraction, I need to multiply both sides by x. And now that I've multiplied both sides by x, the x's are going to cancel on the right. I'm going to have x times sine of a 76 on the left equals 4. And then to get the sine 76 off of the side with the x that's being multiplied, to undo multiplication, you have to divide. So I'm going to divide all of the left side by sine of a 76. And that's going to cancel that out. So I'm going to be left with x equals 4 over sine of a 76, which can be put into a calculator. If you haven't watched the other video of how to solve these with the variables on top, I recommend you do so, and kind of compare and contrast the differences in solving these equations to make sure that you know when you're going to be dividing by the trig function and when you're going to be multiplying by the trig function. So I'm going to turn my calculator on and show you how to punch this in. You'll notice my calculator is in radians. Up at the top it says it's in radians right here. I'm going to show you how to switch that to degrees so that we can do this and plug this into our graphing calculator. The first thing you're going to want to do is hit the mode key. It's right across from the second key, right next to the second key I should say. If you click on the mode key, it'll bring up a menu, and a couple options down you'll see radian and degree. You just hit down twice and there it says radian. I'm going to switch over and I'm going to hit enter, and now my calculator is in degrees. I'm going to hit second mode and that's going to get me out. Now I'm ready to punch this into my graphing calculator. So I'm going to just type in 4 divided by, and the sine key, which is right here above the 7 key, there's a comma, and then right above that's a sine, so I can hit sine and then type in 76 and be sure to close it and hit enter, and I got about 4.12, so x is approximately 4.12, which makes sense because the hypotenuse should be longer than this other side. Alright, let's look at number 2. Number 2 is another example where I've got to use a trig function to solve, but this time I've got a 40. I don't have the side that's opposite. See how it's not labeled with anything, so the opposite side is not given to us. I'm just going to draw a little slash through that. The side across from the 90 is my y, that's the hypotenuse. I'm going to go ahead and label that as my hypotenuse, and that's what we're going to be finding, is the y. And then the last side that I haven't labeled is connected to the 40 degrees. It makes up one of the legs, and it's not the hypotenuse, so that must be my adjacent side. So if I'm given the adjacent side, and I'm trying to find the hypotenuse, I need to use a trig function that uses AH. So I'm going to look down at my SOHCAHTOA, my little guideline down here. OH is opposite hypotenuse. Well, no, I'm not given the opposite, so I'm not going to be using sine. AH, adjacent hypotenuse. Well, that's the combination that I need because I have the adjacent. I'm looking for the hypotenuse. So I'm going to be using cosine in this one. So I'm going to set up my equation so that it says cosine of a 40 is equal to the adjacent side, which is 14, over the hypotenuse, which is y. And just like the first example, I'm going to use algebra to solve for y. So I need to get the y off the bottom. I will be multiplying both sides by y. That will make the y's cancel. On the left side, I'll have y times cosine of a 40 equals 14. And then to get rid of the cosine 40, I need to divide both sides by cosine 40. That's going to cancel, and I'm going to have y equals, and this is the part that you punch into your calculator. So I'm going to type into my calculator 14 divided by cosine of a 40. And I know my calculator is already in degrees because I just put it in degrees, and I'm going to hit enter. So it's roughly 18.2, and I'm going to round up to an 8, so 18.28, whatever units it would be. So that's how you find the cosine, where the variable is on the bottom. Now for the last example. The last example, I've got a 65-degree angle. The side that's given to me is across the triangle, so that's my opposite side. The z is touching the 65 degree, but it's not across from the 90, so that must be my adjacent side. And the part that's not given to us is this long side, and it's the one that's across from the 90, and this is my hypotenuse. So I'm going to write this in here, I'm going to label it, but I am going to mark it out because it's not given to us. So I won't be using the hypotenuse to figure out which trig function I need to use. So on this one, if I'm given the opposite and I want to find the adjacent, I need an OA. So I'm going to look down here. It's not OH because I don't have the hypotenuse. It's not AH because I don't have the hypotenuse. It is OA, so I'm going to be using tan. So I'm going to set up my equation so that it says tan of a 65 is equal to 23 over z. And I'm going to set this up exactly like I did the other two equations. I'm going to multiply both sides by the variable on the bottom. So I'm multiplying both sides by z. That cancels the z's out. I'm going to be left with z times tan of a 65 equals 23. And then I can divide both sides by tan of a 65. And that's what's going to go directly into your calculator. So z equals, and I'll show you how to punch this in. You're going to type in 63, or 23, sorry, divided by tan, which is directly above the 9 key, a couple buttons above the 9 key, tan of a 65, close it and hit enter, and that's going to give you 10.73 approximately. And that's how you find sine, cosine, and tangent of missing sides when the variable is on the bottom of a fraction.